Hi, everyone. Well, first, how about this conference? How cool is this? I mean, I know it takes a village, but Katie and Reagan, let's give it up. Excellent organization. So professional how they did it, and I'm really impressed, and I'm really glad that they're holding these conferences, and I'm glad to be a part of it. Well, it's great that the way Robin set up my talk, it feels like it was a softball, because she was talking a little bit about industrial, and so I'm here to talk about a little bit about that. But that's really just my own particular lens in terms of talking about something that I think is really important. It all comes down to the problem or the challenge of integration, whether that's the integration between multiple data types and domains, or different types of skill sets, the sort of engineers versus the data scientists versus the business, or whether it's manufacturing and industrial versus consumer, but I think it's all about bias, and I think that's a topic. Can't hear me? I gotta turn my mic on. I sound so loud to me.
We can hear you.
Yes, okay, so I am pretty loud. Better? Yes. All right, so my company is in Dayton, so it's an Ohio-based company, but we're global, and I am a consultant, so I've had the benefit of 25 years of being able to see a lot of different companies. So I'm hoping to make this real for you, even though I'm talking through my own bias or lens about the problems of integration and why that's important in getting value out of analytics. So I'm going to talk about my own particular bent. The sector that I'm kind of interested in is manufacturing, and the functions we talked about there are supply chain and process analytics, and analytics that are done in factories, analytics that are done in field, and predictive maintenance and so on. But I think the challenges that we run into there are very, very similar to those in consumer analytics and web analytics. And what is stopping us and what we're doing about it is then what I'm going to kind of focus on. But first, about let's locate this. I was actually, when I was in the restroom and my connected hearing aids started to buzz, I realized, these new consumer IoT applications are really cool. Every week you hear a new one. This Tide Dash little button is I don't know if does anyone know what this is for? This is all connected to the Amazon ecosystem, and push it, and you get another shipment showing up, and of course everyone loved. I mean, this is actually old by now. Hello, the connected Barbie doll. So really cool consumer devices occupy a lot of our time and sort of mental focus. But what I'm actually more interested in is the impact of analytics on industrial applications, because it really is changing a lot of businesses, disrupting them, and driving industrial transformation. You've probably all heard about Industry 4.0. And the difference between these two realms is that when you're doing microsegmentation or web analytics or trying to personalize, you need to be directionally correct and predicting whether someone's going to take up your offer. Nobody dies as a result of it. People might get the wrong offer if you make a mistake, but we have a certain toleration for false positives, false negatives. Whereas if we fail to recognize when the train's going to break down, we might at minimum have a disruption in service. But in the worst case situation, something quite a bit worse can happen. So it's pretty important, and we have a lower toleration for mistakes, false positives, and false negatives. So yeah, industrial transformation industrial IoT is all about analytics of big things. So that's kind of how I think about it. It's predicting the behavior of big machines within their ecosystems, and it's really important to integrate those new sources of data, the IoT data, with all of the traditional and older sources of data, like the master data, what is the asset, where is the asset, and the transactional data, when did it get put in maintenance, when did it get repaired, what are the piece parts that are integrated onto the machine. So it's about really big things. So I thought this little tugboat that helps the big guy park was big, and then I read some of the stats on the Maersk container ship, which contains like over 600 containers, or thousands of containers. There's over 600 of these things, and they're about a football field wide. So we use data and analytics to keep track of where all those containers are, as well as to optimize the problem of, well, if you dead end some of those containers, they're empty and it's essentially wasting space. So that's an important application in industrial IoT. Or, this is actually a pretty cool application. It looks like a big refrigerator, doesn't it? But this company called Einride is developing this T-system, which is an electrified truck, and their claim to fame is they're going to have a fleet of 200 of these by next year, they say, and they're not just talking about electrifying the grid or the mobility, but changing mobility as a system all itself. And so I think you can see wherein analytics comes into play here in making all of these industrial applications happen. So let's talk about some of the most promising use cases that we're seeing and some of the challenges that are happening. So the digital twin is all about taking machine behavior and predicting how that machine is going to behave based on having painted a digital picture of it. So, but it's not just painting. It's not like like in Star Trek. The holodeck is, let's play a beach scene, and it's taking some historical data and knitting together like a real life simulation. But companies that are like rail companies are actually taking this one step further. They're not just painting a digital picture of one machine or one device, but a whole ecosystem, a whole operation. So it's not the holodeck, it's actually a reflection of reality in real time. So you can imagine how challenging that is. But if they can do that, and of course, it's really then important to do the whole space-time continuum thing, going back to the Star Trek theme, is knitting together the sensor data with the transactional data, the bill of materials data, the inventory data, the space-time, where am I at, and what is my environment, and what is the weather, and what is the traffic around me. So it's really important that we don't have silos of data in order to apply our algorithms. And so once we have that data, and I know that Robin is faced with this challenge all the time, as long as we can paint that or stitch together that river of data, and as data scientists, if we can just dip our cup into that water and then deploy algorithms, we can start predicting behavior in real time. But if we can't refresh the data on an ongoing basis, you end up predicting things based on data that's quite old. So machine learning then requires, and machine learning and soon AI requires that we have that integrated river of data flowing behind it, so that we can, if we can do that, then we can predict what's going to happen, and then we can take action and decide evaluate from a number of candidate actions, such as should we take this machine offline to preserve its integrity before something structurally breaks down, or should we divert it somewhere, or the truck is going to be late, so should we send another conveyance and make sure we make that appointment on time, so we can decide the next best behavior. So that's where AI and machine learning is starting to be applied. But notice, you can't just jump to the AI or the machine learning before you've done some of that hard data work. Right, Robin? Okay, so really just another example of this. This is a haul truck from the Large Power Systems division of Caterpillar, and it's part of a fleet of mining trucks that are out there, where, remember what I talked about, a low tolerance for error. What they were trying to do is predict which of the machines operating at a mine would be likely to fail today, because if one of those $3 to $5 million machines breaks down, I mean, forget the capital cost of not having that thing working, but it gets stuck in the mine shaft or in the mine road, and no one else can get by. So it's really important that they know which one is going to fail so they can take it offline before it actually fails. And yet they might have 100 of these at 4 or 5 different sites. And predicting which one's going to fail is the goal. But at the time we started working with them, they could only do one prediction a night. And they could only evaluate one engine per night. It was that computationally intensive. So what we had to do is not only integrate the data, but allow it to be done at scale in a massively parallel fashion so that they could predict all 100 machines and say, well, which of these reaches the threshold of being likely to fail, so that they could actually understand which single system was going to fail. And so that the goal then is to deploy that across all of their mining sites and potentially bring it closer to the site where they could run it at the mine site rather than run it centrally. So they're not there yet, but they're doing the fleet-wide prediction, and they're able to, on a nightly basis, tell the site manager what's the useful life of all of your trucks that you've got in operation, which is the most likely to fail, so that they can potentially avoid that downtime. Okay, this is actually a local example. It's a smart mobility analytic example, and this was a challenge we set up for Hack Ohio, which was a hackathon that we contributed to in fall of last year. And so the idea was that if you could knit together multiple domains of data, so like resident, geolocation, and movement data. Here's an example of a particular user or driver's destination journey through Columbus, and then aggregating the sort of slowdowns and traffic patterns and visit patterns, and then actually analyzing the pathing. That was the challenge we set up for them, and they were. This was actually done and taken on by a couple of student groups at the hackathon. And they actually this actually are screenshots from. I should have gotten them to enter that really cool visualization challenge. But this is the actual real life how it was deployed, which provided a commutability story, a commutability score that potentially could be used as an enrichment to Google Maps, for example. So that was like the personal user view of this data. And then there's also a urban analytics, urban planner view of it, so that if you're trying to say, well, how should I change bus routes, or how should I change the location of bus stops, all related to the first mile, last mile problem. Another application, here's where we're starting to use deep learning and object detection. Can you see that? Well, this is, they're not predicting anything yet, but they're using deep learning to say, well, and this is where I sometimes scoff a little bit about AI, because it's like, okay, I can recognize a cat. Oh, there's a mug. And I think, my cynical side says, is that really contributing to society? But if you can start, eliminating the object detection sort of ideas and then integrate it with other in other settings, and rather than using it in isolation and by itself, then I think you can really start augmenting rather than replacing existing systems. So, and just a zoom in on the types of data, so the visuals, the GIS kind of data, and how that renders itself in the data side of things. So the data integration challenge here is pretty intense. And then lastly, so that whole object detection, camera and computer vision emerging use case is starting to be applied in the factory of the future. So in Industry 4.0 settings, if we're already building a machine learning physics-based model prediction of which asset's going to fail and then disrupt the process, or which environmentals or other measures or other PLC data is contributing to or can tell us about the cause of, say, a yield problem or a bottleneck. Then if you've got that and you've got a certain amount of predictive power in your models, then if you can incrementally add camera and computer vision data, then you can kind of superpower your predictive algorithm and add, that last 5 points of predictive power to it. And so we're really starting to see some so I'm losing some of my cynicism about AI and camera and computer vision, because if you can combine it with other industrial information and other industrial methods like I described, then it really augments rather than replaces something that you had before. So I'm hoping that I set the table in terms of what kind of applications and some of the challenges being data integration, skill and domain integration, and even the ability to recognize a method that's being used in, say, aeronautics versus process industry versus, and even applying that to consumer applications. What I wanted to talk about next is, this is the challenge. I mean, the possibilities for achieving value are tremendous. This is an actual scrubbed version of a business value analysis that we did for one of our big industrial companies. You might be able to guess what kind of company it is by some of the graphics, but not to go into any detail, but to highlight, these are pretty big numbers, pretty big savings in cost of goods sold and SG&A costs. If we can get that, that's the motivation. And so, again, these are not trivial pursuits. So what is keeping us from being able to achieve that? So it's a collection of different things, and I think these are really, really common to every single analytics walk of life, whether it's consumer or industrial domain, whether it's web analytics or industrial IoT. The technology differences from one place where we get the data to another are barriers. Physical access to the data. When I started a supply chain business in the late 90s and early 2000s, our biggest challenge then was just getting, if you're talking about supply chain and coordination between multiple companies, getting those companies all to serve up their data to one central coordinating unit was a real challenge, and access to data was a real challenge. It's still the same today, but there are many more new ways of getting at the data. The discovery analytics is something that a lot of you are probably data scientists, and so discovery and mining insights out of data is one of the things you do a lot of course, right after you've done all the wrangling and so on that allows you to do that. But then operationalizing it, and they're very different. They're very different worlds, and we'll talk a little bit about that. And then the domain silos. It's really, really important to make sure that when we're data scientists, that we don't do it in isolation of the business analyst, the data engineer, and even the executive management. So those domain silos. In industrial settings, these issues are sometimes intensified because now we're starting to talk about getting data from the wild, where it's messy and we don't always have electricity or we don't always have signal. And it's a cybersecurity risk. We have brownfield plants that have, like the automation equipment isn't even attached to the network sometimes, versus, in the consumer world, how old is your cell phone? Is it more than 5 years? Probably not. Most people, especially if you're doing the rental version, you get a new one every year or 2 years. In operations technology, we're talking about multiple generations of operational systems, and so bridging that gap and getting the data from all of those whilst maintaining security around it is a real challenge. And then I can't stress enough how much, the guys who are manning oil rigs and the people who are actually maintaining industrial machines and plant management and supervisory staff and line supervisors, those folks who, I mean, they don't talk to each other, let alone talking to IT. And the types of methodologies we have in IT and how we do things there are very, very different, and they require an explicit effort to make sure there's communication among them. So I'm going to talk first a little bit about this chasm between. No, I'm not. I'm going to talk about the domain silos, so ignore the blue. So I think I've alluded to this, that by themselves, one domain of data, say sensor data, is limited. It's only in our ability to analyze the patterns that we might see in the signal that we can make sense of them. But even then, it's not all that usable. So for example, if I wanted to figure out when a train or a unit or some sort of machine on the train was going to fail and do something about it, look at all the things I'd have to do. I'd have to get, in order to answer these questions, look at how many different types of, these are what I mean by domains of data. So in order to ask and answer any really valuable question, I actually have to marry that river of data that I might be storing in Hadoop to the data where it's very structured and I've collected all my transactions, or my HR database where I know what the skill set is of the engineers that are on staff today, or my supply chain data source, or my ERP system where I know the bill of materials, or I know the availability of spare parts to replace that. So it takes a whole set of villages of data to answer those questions. So that's what we mean by the challenge of integration. So as an example, if you think about and this graphic is really meant to depict the fact that you've got sort of disconnected and unstructured data that's in your ecosystem, the semi-structured and semi-connected, and then the highly structured transactional and master and dimensional data. But if you look at just this example, this is an example based on predictive asset maintenance, which is the type of query and algorithm that we were talking about on the previous slide. You want to get sensor data from your manufacturing area. You need your bill of material. You might need to know about customers and what assets. You might need to understand field events and what maintenance has been already executed, so that you know what's the business context in which I'm making this analysis. So our conscious, explicit framework and methodology in how to integrate these data are to say, well, what types of users and use cases are they going to be used for? Is it users that are primarily doing experiments? And that dictates one sort of organization and data layer. And I'm not going to talk about specific platforms, but it's a framework that we use for organizing, form follows function. So really, whether it's, and this is prescriptive as to what we recommend companies do in terms of creating this layered data architecture to support analytics. So a staging area where you bring in atomic level data in an original form. You start integrating it. You start doing some minor repeatable calculations. You aggregate it in some form, you present it, and then you also have means and ways of enabling data and experiments in the data lab. So that's kind of a really just lightning fast the integration approach that we're prescribing for data and how to get to bridge the gap between data domains. So now I'm really going to talk about the chasm between discovery and operationalize. And I could, there's a whole presentation on each one of these challenges, and I only kind of chose two of them today. So we understand what I'm talking about in terms of discovery analytics, right? That's like ask a question for the first time or see what's in this data. What insights can this new source of data reveal for us? When you're doing that, you're talking about polar expeditions or circling the world, or going on tracks that you have not previously traveled. And so if you think about the kinds of tools you need, the kinds of skills you need, you're doing iterative creative work, you're doing hypothesis generation, your workflow is very ad hoc, depending on, you need to go where the data sends you. And you're not traveling on well-worn paths. Whereas, let's say you've discovered a way to predict something that really informs the business of something, and you want to productionalize it. So you got a rail, you got to lay tracks, right? And you can't, the rail business is not an ad hoc mobility solution. It has to go where it has to go, right? You have to set up production lines. You have to schedule and have very rigid procedures. IT lays down the guardrails and the service level agreements, and they've agreed that they will serve things to users in certain time frames. You need to do monitoring and alerting along a strict operational model. You have service level agreements and standards that are there for a reason, and you need to have a well-defined workflow. The rails, you have to lay down those rails. So I can imagine that, and we can all imagine that the skill sets, the interests, the types of training, and even the language that people in the two realms speak are quite different. It's very, very, there's a translational gap here. So one of the things that, and I think Robin mentioned this when we were talking at dinner last night about how we do deployment, which is kind of how you bridge that gap, how you convert your model to run in the polar expedition mode versus the highly scheduled air traffic control mode. There's a translation that has to happen. And 5 years ago, this was like a dark art, and there was just a very, very few people who knew how to deploy analytics at scale, particularly when we're talking about industrial scale, where you may have hundreds of thousands of micro models, potentially one per asset in your fleet, or potentially one per intersection, or whatever your unit of prediction is. And you have to understand and go through that policy procedure fit and the process integration. So the framework that we've chosen and developed over the last few years is called Analects Ops, and we called it Analects Ops as a riff on DevOps. So DevOps, as you guys know, is a software development discipline that's emerged over the last 5 years. It's kind of a spin-off on Agile. And what it's done in the software world was say, we don't have to do everything pure waterfall, because we all know the danger of that is that you write this massive requirements definition. That took 6 months. And from the time that you talk to your users initially to when you actually started coding, the requirement changed. So we broke away from that with Agile so that we could do, so we could have a backlog, and we could have a process owner, product owner, and a Scrum Master would lead small integrated teams that had one of each of the domains, the data engineer, the IT person, the data scientist, the business analyst, and executive sponsorship. Well, we took that whole model and created that as Analects Ops. So that's the whole notion of taking data all the way from discovery and all the skill sets and different skill sets needed in the discovery frame and the tools and platforms needed there, and planned ahead for this will be deployed. If it meets certain bars of acceptability and certain standards of false negative, false positive, and hits those, it will be deployed. So then we need to manage the metadata of the model we created here in Discovery through to where it's deployed at scale and potentially has to be version controlled. So, and we do that in very short spurts of agile teams that do that, and we've professionalize that whole process of manufacturing analytics. So this DevOps for data scientists, called Analects Ops, is a framework that's explicitly been created to bridge the divide between data scientists, software engineering, and deploy a DevOps for those two worlds. And we've had some pretty good success using that. If anything, it kind of recognizes that data scientists and IT and business in the different domains are different. It creates a language for them to talk to one another, and it allows us to plan ahead for what has to be done for that deployment into analytics. And it even helps to update the model while it's running at speed in production. This is really just a drill down on some of the components of Analects Ops, which I won't just go into in too much detail, but from the development to the automation to the consumption, that's getting to that consumption and industrial strength analytics at scale is really the goal and the end state vision for getting value out of analytics. So when you think about that whole notion of the problem of integration, whether it's integrating data that's from many different settings physically, from many different types of systems, many different types of verticals, and the whole skill set gap between data science who are doing discovery to IT or who are trying to support and run the models. It's really a problem of integration, and I think, and so I'd invite you, and so I come from a supply chain, industrial, and manufacturing background, but I can bet that especially in Columbus, there's a lot of banking and healthcare, and but there's some industrial as well. I hope that this resonates, that these same challenges exist in every one of your your companies, and I think going forward, consultants have this ability to see many different situations. So I could kind of abstract away what's similar and what's different about them, and so those are the sort of challenges and learnings that I hope make sense to you, and I would invite you to try to make sure you're not doing things in isolation. If you join an analytics team, to ask the question, well, how does this serve a business strategy? If you're a data scientist, how do I make sure we plan ahead for what IT is going to need from this, and not work in isolation of the business analysis. So I'll leave you with one story. We worked with one client who had a central analytics team and was going to embark on a yield improvement exercise through and analyzing what factors what factors contributed to yield problems and scrap. And they had a group of data scientists who were going to attack this problem, and a bunch of them were. Some of them were, new grads that had, advanced math degrees, and some of them were, seasoned, stats guys, and some of them were, sort of in the middle and had come from other industries. And we started with them, and my first, in the kickoff meeting, it was like, okay, so here's the part where we take the plant tour, because, that's important, right? And they're like, well, why would I want to do that? And I'm like, are you kidding me? I mean, you're modeling the behavior of this line. Don't you want to see how it operates in the wild? So I would invite you to keep that curiosity of this is a digital model of something that's happening in the real physical world. Don't lose that connection between those two worlds. So that's kind of the challenge I wanted to leave you with, and I hope that made sense and spoke to some of you in ways that related to your own experiences. And I thank you very much for the opportunity to talk to you guys this morning. I think there's
5 minutes.
Time for questions. 5 minutes. Any questions? There is a stand-up mic here, and it's probably on. But I can also hear you if you want to just raise your hand.
Raise
Yes.
far. So it seems like you have had a lot of experiences with a lot of different companies. Would you say that it's basically the challenges are over and over the same, or is it getting better? Because in my previous experience, it's usually we always have the same problems, and it doesn't seem to be getting too much better. But how is it with you guys?
So the question is really, in all your experiences, does it ever get better? Is that fair statement? You know, industries do evolve, and you know, I was one of my customers invited me to read their favorite book the other day. It was from like the late '80s. It was done by Bain and Company, and it was like super quantitative, but it was pretty old school. And I thought, you know, look how far we've come in this one domain. It happened to be a book about competing on time. And I said, like, that is so obvious now to us 10, 20, 30 years later. So there are incredible advances in management techniques that may seem frustrating today in 5 years. You know, oh God, I still have to remind people to set goals and like revisit the goals at the end of the project. So sometimes it feels like we're not making advances. But I can tell you from my experience, the movement sometimes seems glacial, but if I look from industry to industry, you know, different industries are at different points in the development, and sometimes it feels like we have to relearn lessons again and again. And I would say that there's some industries that are way too insular. Like I spent probably 5-7 years, I live in LA, and I spent 5 or 7 years with all of the media and entertainment companies that were based in Los Angeles, so all the Hollywood studios. And those people all, like, they go from Fox to, you know, Warner Brothers to Sony to Disney and back and back and back and back. And so they weren't, and so at one point, Warner Brothers started bringing CPG folks in to run their supply chain for their DVDs. And they finally started learning, oh, this is how you do demand forecasting, and not just like push as much product into the supply chain because, you know, that'll make it sell faster. And they started learning. So, I mean, I would say, yes, it is getting better, but it is getting better insofar as people overcome their bias about their own industry and allow some learnings from other industries and other domains and other disciplines into their sort of view, and you know, think about their own contribution to this. There's a question back there.
Who are data scientists in the industrial world? Do they have to be consultants, or do we augment the skill set that we already have from a subject matter expertise?
I think that, who are the data scientists? I mean, today the emerging data scientists in industrial settings tend to be tend to be in plants, tend to be the process engineers, and honestly, the newer college graduates coming in don't have the old school skills. Like, you know, for example, 20 years ago, every engineering student graduated with MATLAB and sort of these sort of low-level statistical tools that happened to be free to the college they attended. Now students are graduating with Python skills and R skills, and so they can make that leap. But then when they infuse, and when these plants bring those kind of folks and have like a kind of a cross pollination of ideas from plant to plant to plant, sometimes what happens is that the process engineers, the manufacturing engineers at that plant start to take on the new skill sets. So it comes from within and from outside. I think it tends to be, it's easier to gain data science skills with someone who has the scientific or the domain expertise and intellectual curiosity. I think it's easier to learn the data science after the fact than it is the other way around. But another way is to fuse these, like we call them pods, like these scrum teams, fuse the business, the business domain expert, which might be a process engineer, to a data scientist, to a data engineer. But the vast advantage the OT world has, the operations tech world has, is that they tend to be engineers. They already know the math, they already know the science, and they have a deep regard for how the actual process works, and they've walked the plant. So, I think it's really a mindset that keeps them from adopting data science as a fusing Six Sigma and Lean with new sort of data science and big data techniques. It's mainly a mindset shift, and they do tend to have limited budgets for bringing sort of big data environments to bear. So it's very challenging, but I think it's both organically sourced, but insofar as you can infuse a few people who have been elsewhere in other walks of that own company, but it can also be consultants too. So don't get me wrong. I mean, I am a consultant, so yes, it can be consultants, but it doesn't just have to be. And sometimes it's about setting. I mean, what I've seen in the industrial world is you set up your model plant, and that's where you take the best of you cherry pick people from various groups, and hopefully bring that multicultural sort of mosaic and pod team together and design what's the ideal, and then you take that road show on the road to the various different plants and hope for some adoption. But anyway, those are some of my ideas about it.
One more question.
One more question?
I have another question, if that's okay.
Who is that?
I'm here.
Oh, okay, sorry.
The return on investment slide that you showed on an aeronautics industrial company, what was the time it took to get that return on investment? I'm sure AI and machine learning is not going to be a 12-month return on investment or a 24-month return on investment.
Oh,
how did you gauge the return on investment, that the dollars you showed? How do we convince the leadership in enterprise to understand that?
I have a radical opinion on this. I think I've seen a lot of industrial companies do something at the corporate executive level. Sometimes they pair with like a startup, or they'll buy a startup. But if you want to actually change those brownfield or semi-brownfield or greenfield plants, I think you have to do guerrilla warfare, hand-to-hand combat in the plant. And when we do that, you have to take one line or two lines and experiment the process on that one or two lines, and I think that needs to show investment return. But don't take on too much and don't boil the ocean. Take one or two. Like, we're starting this project right now. It took us actually 6 months from the time we met them at a conference, and they were considering predictive analytics in their plant, till that was like in August of last year, and we're just kicking off the project now. So it took them a long time to get the right sort of sponsorship and support, and it's a very, very small project. It's going to be a 3-month, but we've already done the predictive model. Now it's all about deploying it on the line, and some of this is like hooking up SCADA equipment and making sure we get grabbing PLC data from the machines. And we specifically chose those two lines because they had the worst yield and scrap problems. And we knew that if we affected that, it would have a isolated, just on those two lines, it would have a return on investment within 10 months. And then we could go to maybe the less problematic lines and scale it out to the rest of the plant. But then we plan to do that in a neighboring plant and another neighboring, and then having a couple of examples of how these techniques work in very specific form, not just like throwing technology at them, but actually solving the yield and scrap problem, then we're going to go to the chief operating officer of that division, not the corporate chief operating officer, and say, you know what, here's some stuff that actually works. And now we can start thinking about, well, what would be standard technologies and platforms that you might want to apply in a whole connected factory situation. But for now, we're just doing this one battle at a time, line to line. So I think that first, if you do it that way, it has to be inside their operational year that it pays off. And so you have to be really, really sure that you've got everything set up so that when the clock starts ticking, in 12 months later, you've actually deployed the technology and had 9 months of operating successes. So that's my. I think a lot of other companies come in and make deals at the COO level and try to push technology and processes down. They don't actually deal with, well, what business changes are going to happen to prevent scrap from occurring in this large power systems assembly operation, or this high pressure valve assembly or extrusion process. So I think that's my opinion anyway. It has to be less than a year, and it has to be done at a local level before expanded to a global level. And I think that's
all.
all the time we have. But thank you very much, Ms.